Thank you all for having me here once again. I want to talk about something that's been on my mind lately, challenges, hope, and I was hoping to, before the end, solicit from you all what it is that, the point where you turn the corner from criticism to constructive move forward. I'll start with the first part, and I'm hoping you all can help me take the second. So, to get started, I want to run through a couple definitions, what it is that I mean here. By DSL, Durston, Clinton, Visser, and the tildes there because I'm vastly paraphrasing. I mean a programming or executable specification lang that gives some kind of notation or abstraction, useful expressive power in a focused, restricted, limited domain, and hope that limiting the domain makes it more useful in that area, a language for doing that. This is something that Bentley described in little languages. I wrote programming pearls there, but I should have said his little languages. But also this is the kind of thing that Lisps have had since time immemorial, the ability to design these little special purpose languages. Enough so that we've got a whole kind of phylogeny about what we mean by them. Martin Fowler coined the term internal DSL. I think Paul Hudak was the one who gives credit for embedded domain-specific language or domain-specific embedded language. And by this I mean something where it's the language is inside some host GPL. It's not a standalone special purpose language. It's sitting inside some host, and the internal DSL uses at least some part of the host, either concrete syntax, it's maybe basic static or runtime semantics, and some of the whole general ecosystem that you get with your host language. By deep embedding, one of the two ways to do that, they call them shallow and deep, and in a deep embedding, the elements of the DSL are host language values. Think of it like your DSL's job is to build an abstract syntax tree, and then you have an interpreter or compiler inside there that's going to do that's going to execute your DSL program, perhaps check it or do some optimizations in front of it ahead of time. By contrast, the shallow embeddings are the kind where there's not an explicit AST built, but rather the objects of your DSL are actually code fragments in your host language. So there's not an AST built. Instead, the evaluation of your DSL program is actually a direct consequence of evaluating the host language program in which it's written. So the picture we should have is all computer languages, and then there's a specific subset of the DSLs, and some of those are internal DSLs, and between the deep and shallow, I'm saying that I'm going to focus today on the shallow ones. There will be analogous concerns for other ones, but I was narrowly focused on this, and so that's kind of where I wanted to draw your attention. For example, I had in mind things like the Linux kernel build language, the language for Gradle to do project building. Kbuild is a embedded DSL inside the make language. The project building Gradle stuff is embedded inside Groovy and then more recently Kotlin. There's a climate modeling DSL called Mimi embedded in R that you all have likely never heard of, but amongst a class of climate modeling science experts, this is their language for programming in. The Chisel hardware definition language is built into Scala. There's Minicanron, constraint logic programming near and dear to my heart. And I also have in mind by this a lot of libraries with kind of a unified, coherent API are really embedded domain-specific languages that are struggling to get out. The difference between a language and a library can often be that the library wanted to be a language, it just doesn't have the kind of implementation infrastructure, or ahead of time support that a good language should give you. And there's many other examples that we've seen this week at ICFP and elsewhere. I stopped counting the number of little embedded DSLs that we came across, but this is something, the kind of thing that we like making. And people keep making EDSLs, partly because it's ease of implementation. You already know really well how to write programs in your favorite language, and if the implementation of this language is just another program in your favorite host, then you get to apply the full breadth of your tools and toolkit. You also get to reuse some of the host language functionality. A lot of times the person who's building a language has first and foremost themselves as a user, and you already know how to use your IDE's debugger, your host language's decompiler, you know the infrastructure for that language, and so you get to inherit a lot of that. The DSL works with your IDE, and it also works with your host's package management. It works with your module system. You know how to write documentation, all the kind of tooling, external infrastructure that you're used to and enjoy, you get to inherit for free. It's kind of a really quick jump start on getting a whole ecosystem for your little DSL language if you can inherit a bunch of it from your own favorite host. That's a kind of bargain people jump on. So if you get nothing else from this, my thesis is that EDSLs are a thing and will continue to be. There are programmers who will want to learn to program in these DSLs specifically. Some of them may be coming to program specifically to work in these DSLs, and these learners deserve support in doing that. So I say, I underscore that to talk about what I mean by that support in terms of teaching languages. And teaching languages are something that makes sense in the context of DSL, but they also make sense in the context of programming languages more generally. My contention is that your favorite programming language fails novices, and that this is the reason that there's so much contention over what the first semester freshman year programming language should be, what the first programming language should be. It's because everybody can point out the flaws in everyone else's favorite language for a novice audience. And it's not because their favorite language sucks, it's because they all suck. And I mean, obviously there are important differences that come up. Don't read it. It's just the consequences of one first programming language. I wanted something from the 80s talking about how the first choice of programming language matters. I'm not saying it doesn't matter, and we've all heard Dijkstra, but I just mean to say that your own favorite language is pretty complicated. It's fully featured. It's designed for a working, adult, mature programmer to work in. That's why you like it. So it's definitionally somewhat obscure to a student who doesn't know programming or doesn't understand that kind of programming paradigm. And it's speaking in a specialized vocabulary that assumes the audience, the reader, knows what it means. Students who are learning are definitionally in a context where they are the wrong audience for the language of your dreams. And that's true whether you're in Perl, Python, PHP, Prolog, or Pascal.
And if the language name doesn't begin with P?
Yes, even those. And so, because I'm here at the Scheme workshop, I wanted to, well, dun dun dun. But people talk about Scheme as a teaching language. And I tried to pick some reasonable places where we, as schemers or parenthetically inclined people, not necessarily off the cuff, talk about Scheme as a teaching language, but I hope to convince you that that's not what I mean by a teaching language. Languages that are used in education may or may not be teaching languages, and most of them, under a strict definition that I have in mind, aren't. So, what does this program do? Quickly, to my schemers in the audience. Let me see a hand. Yes?
I took it back down, but I think this is just adding 1, 2, 3, 4 until the length of this thing or something like that.
Absolutely. It takes the length of a list. Specifically, if that list is of length 0. And only if that list is of length 0. You will have noticed I accidentally forgot a set of parentheses here around my add 1. So in con, we'll ignore that and just recur. And so it's a very specialized linked list function. Cameron, what does this program do? Why?
So quote is overwritten. You have a quote before. Oh, wait, hold on. Oh, you're going to add quote and a quote.
Is it going to be 4 squared centimeters or 0 squared centimeters?
Yeah, way to go. Yeah, I didn't know I was overriding quote. I just wanted to use the identifier to make a quote thing. That's a perfectly fine thing to do. One of my favorite examples in class is you build automobiles, and wouldn't you know, define car. Perfectly grand thing to do, makes all the sense in the world. Mitch, how about this one? This is a little less likely, but but it does. It heats the room up for me. Another one, Andy, my scheme implementer in the room.
It invokes the non-procedure.
Yeah, I will get a big, ugly, nasty error message because null is true, of course. It's true enough, and then so we'll try to invoke unless I happen to give it a thunk as input to the program, in which case I might get, if I'm lucky, 0 back out. So, and there's more of them. These aren't the kinds of things that you would put into textbook. These aren't the kinds of programs you would throw at a student. And these are the kinds of things that we can look at and say, oh, yeah, I know, but that's just kind of a side thing. That's not what I mean. But these are the kinds of things that students encounter, and we don't have a way to control when it comes to them. Yes?
So at what point do you draw the line between saying, that kind of thing is going to happen as part of programming, and learning how to figure out how to debug it is a necessary step, and saying, well, there should be more guardrails so that kind of thing can't happen too early?
Yeah, I don't know. Yes, and? But actually, the literal question, I don't know the answer to, and that's one of the things I wanted some help on. I'll circle back to that when we get to it and show you diagrammatically what I think you're asking. So, yeah, it's not scheme that I'm picking on, it's all of them. And my students end up confused, intro students end up confused no matter what language they're using. So, this is the slide I stole from Matthias Fleisen, describing what the right role of teaching languages or a family of teaching languages is. The blue is the ideal curve. As students get more and more experience, the ideal is that they should get a gradual ramp up in difficulty of the programming language that they're working with. As they learn more, their language should respond, give them more power, and give them error messages in the more complicated subset of the language that they understand. They come into class at the end of the first week. They have homework, but they haven't by the end of the first week understood the full language. And so what happens is that invariably at some point they're required to make a massive jump up in their understanding. And we, right now, I think one of the common practices is to throw them in, and at some point they find themselves in the deep end, and some of them will be able to jump up and grab a hold and figure out, and that's when they've understood the majority of the language. But there's a hurdle that they run into, and we don't really have any say in when it is they hit that, because it's not when they write in the programs that we've taught them in class, but it's when they make a mistake typing that in, and the error message responds to them not in the subset of the language we know, but in the ontology of the full programming language. Almost everywhere there be dragons. And the idea of teaching languages as a sequence is to help smooth out that gradual ramp up by building a concentric sequence of languages with their own implementation that actually is speaking to a user just in the vocabulary of that implementation, so that at every level, the gap between a complete novice in that language and somebody who fully understands the semantics of that language is relatively small. And so hopefully the jump they need to make is small enough, and we can control when you go to the next step in a way that we didn't have the ability to do beforehand. And so this isn't something new. In 1977, pretty early on in the field of computer science education research, Schneiderman suggested the spiral approach to teaching languages. You should teach a small, usable set and then slowly grow, reinforcing the part that they've seen while you teach them new stuff. And they should be able to write programs in the small set as they grow and grow as developers. And in the same time, in CACM, 1977, Holt and his posse, I think out of Toronto, said that this idea that students deserve language support in doing this. That spiral ought to be something that happens in the context of a tailored language and a sequence of languages that grow. So they were building families of teaching languages for PL1. And I think that's just cool as all get out, something in 1977 doing that and having that idea. So in the Dr. Rackett family of teaching languages, when we make one of those mistakes that we saw in that earlier program, I will get a static syntax error. I didn't have to run the program. I keyed it in, and I get an error message that add one expected function call, but there's no open parenthesis before where that's supposed to be. It highlights the source of the error. That's pretty nice. Maybe it wasn't that nice, that easy an error message. Maybe it wasn't something so purely syntactic. And if I press the run button, I'll get a nice error message that's describing the problems in terms of things that could go wrong in this small beginning student language sublanguage. Yeah.
So this is a question I genuinely don't know the answer to, but in this case, this just seems like a better error message. So why doesn't Racket just do this? Is it because you just couldn't do it for all of Racket because the constraints of the teaching language allow you to recognize this, or is there?
Well, sometimes, maybe that's a good question. I don't know. Is it backwards compatibility?
This is a perfectly valid Racket program. Add one.
Right.
Yeah,
right.
But why
it
would
is
you,
right.
yeah,
Okay.
But why would you want to?
Right.
Why
right.
is that a valid Racket program?
Right. It should be a warning or something maybe, or a linter or something like that, I guess. Or
My guess is backwards compatibility with Scheme, from which that was allowed.
right. Like there's an implicit begin, I guess. Right. So.
Yeah, it's an implicit begin, and I guess why would we stop? Why would you allow some expressions here rather than others and complicate the grammar?
Right. Right. Makes sense, yeah.
Yeah,
Would require you to analyze effects or something like that. Like, but in this case, because there's no effect for the first one,
Right.
that's kind of the reason why you would expect this would be. Yeah. Anyway,
Yeah.
it makes sense.
That's a grand answer. Yeah. All right, so in addition to the PL1 Holtz's group doing PL1 languages, the PLT Scheme group in about 93 had a similar idea. And we've got teaching language, not just languages, but language families. A couple for Java. There's the Grace family of languages, Hedi for Python, Helium for Haskell, Forge for the Alloy language, something I think that came out in a nice paper earlier this year. There's a whole lot of work on teaching on languages that are designed to be used to remove some of the warts. But there's not a whole lot of work that's been geared toward building these concentric groups of languages. You can treat any particular one-off teaching language if they've got in mind a trajectory, getting you from baby Pascal to real Pascal, or getting you from baby CPL to real CPL. You can treat that as kind of a degenerate case of family of teaching languages where the family is of size 1. But beyond that, there's a lot of work, but not a ton of it. So some of the limitations and problems with this approach, there's great benefits to doing it, but it takes a large amount of work to create these kind of teaching languages. Right now, the Racket people sort of had to reverse engineer Racket into a language-oriented programming language so that they could support building these families of teaching languages. And there's been a goodly amount of work on coming up with the right kinds of error messages, like field studies reporting what it is that students understand. Things that make sense to a programming languages person or an implementer don't make sense to students. There are distinctions that Racket had been making in these teaching languages that now they don't. It takes a group of expert craftsmen a fair amount of time to build these sort of things. And I want to live in a world not where it takes expert craftsmen to build it like a cathedral. I want not quite franchised like a McDonald's, but I want it to be a lot easier for somebody who's interested to be able to roll out a family of teaching languages with some target endpoint in mind. A consequence of the difficulty of maintaining those, of building those languages is that if you're trying to target a real-world language like Java, then it's real tough for your small posse of teaching language people to keep up with this speed and intensity at which the Java language moves. A fair number of these projects that have been designed as teaching languages for X have kind of bit-rotted and fallen by the wayside because the group that made them hasn't been able to keep up with the actual factual implementation, and now the gap between the language that they had teaching and the language that's the target language is so far away that maybe the teaching language isn't really an effective jump, or the language paradigm has changed enough in the meantime that the way you learn to program this teaching language, that's not the Java we use nowadays. The other thing, and this gets back to a question that Chris was asking, and how I interpret it is that it's also right now kind of an art as to where the jump should be. What level of, how many languages do you need to go from beginning point to where you want to get? How much of it should be left to the, well, student, you should learn to struggle and understand the idea that this error message is conveying to you, and that is how you learn. The idea of digging into error messages, consulting documentation, figuring out what's going wrong and solving the problem in quick succession is one of the skills that we want to imbue in our students. And I don't know too much in the way of curriculum that actually has an explicit way of teaching that. But also, we don't want them to have to make the entire jump at once. There should be a better way to teach programming than sink or swim. and coming up with the right metrics for what jumps should you have, what should be the new idea that you teach in the next level, how is it do we get from language 1 to language 2 to language 3, what does the progression look like, is another thing that we don't really know the answer to, I don't think. And so back to the EDSLs. I think of EDSLs as kind of a worst case scenario for this sort of situation. Holt in 1977 is describing educators and students and employers have the advantage of a more widely accepted, for them, the advantages of a widely accepted language outweigh any advantages of additional elegance in a teaching language. And the temptation to invent yet another teaching language that ought to be ideal for teaching certainly should be resisted. Not only are they describing the idea of families of teaching languages as early as 1977, they're actually already over the idea of the solution being another teaching language. I like that in 1977, oh, not that again. And some people want to learn to program in whatever EDSL it is that you've got in mind. The way people want to learn to program in some particular real-world language, like Holt is describing. Some of the people that we're interested in helping learn to program want to learn to program in EDSL, in an EDSL. So one example of this that I mentioned earlier is some of the kernel, Linux kernel hacking folk. Maybe I need to do some recompilation. I can imagine somebody who's, I'm not interested in getting into the guts of the makefile, I just want to learn to program in this language. Perhaps one that's maybe where the audience is a little bit further removed from the people that are developing the language. Reynolds and Chasins described this last year, a kind of study of a group of users who really want to work in an embedded DSL. The Mimi one that they have in mind, I thought this was just a beautiful piece where they track some people who want to learn to program, and their goal for learning to program is to do climate modeling in this Mimi language. Some of the users, the main story is that these folk, they're trying to learn to program because they want to do climate modeling, and this is the gold standard for their community. The language that they work in is an embedded DSL in R, and so this is what code in the language looks like. It's a little small for you to see, but the idea is that it should look like R code, and you can see up here on line 30 that they're using Mimi. Oh, yeah. How do you? Okay, well, good. So some of the things that they found was that users had trouble distinguishing what went on in the host language and what was going on in the DSL. When an error message happened, is that coming from the DSL or the host? Even as far as I imagine if you're looking at a stack trace, what should I be paying attention to and what should I be ignoring? They also found that there were some problems with using punning in the DSL using similar syntax with slightly different semantics. That places where in the host I'd be able to use either of these two expressions interchangeably. But in the DSL, for some reason, I can use this because it's been special purpose, but not this. Users tended to have a high dependency on DSL-specific resources. They found that the Mimi programmers were going to the Mimi documentation. Even if something like the package management system wasn't specific to Mimi, I'm not a Julia programmer, I'm a Mimi programmer. They found that some of these people were using their domain was small and bespoke enough that rather than starting from a blank file, they would take some existing example code and try and tweak it to their uses, where maybe they're getting the right answer out, but their program is terribly inefficient or written in a way that may be doing unnecessary work and as a consequence won't scale to what they need it to do. And they also found that the host language being responsible for important parts of the ecosystem meant that these folk who learned to program just in Mimi found themselves struggling with things that were that the DSL was expecting to inherit from the host that these users didn't know anything about. There were features they didn't know they were missing or didn't know were out there, and they didn't know how to discover them. So another example of a kind of EDSL that people desperately want to learn to program in is mini-canron, near and dear to my heart. I want my students, maybe sophomore, junior year students, to be able to learn to program in logic programming. This is a very different style of programming. There are certain kinds of things where when a logic program is the right tool for the job, you can't imagine doing it any other way. I maybe don't want to program generally in logic, but if I'm trying to write a graph coloring register allocator, it sure is nice to be able to do a graph coloring. Or if I'm writing a little type inferencer, writing as a logic program makes me sorry that I have to write it any other way, or when I have to leave the subset of type inference that I can do in a logic programming, I'm kind of sad when I wave goodbye. But my students aren't experts. They maybe have had a semester or two working in the racket teaching languages. They don't know racket programming. They know some of the teaching languages. And I want to make sure that I can get my students able to be effective mini-canron programmers. So for the mini-canrists in the non-mini-canrists in the audience who haven't seen this yet, an example of a mini-canron program is this direct relation, where it's describing a database where each of the lines is a row in the database, where the from direction A is Boston or Houston or Seattle, and the to direction B is Seattle, Salt Lake, Denver, Boston. And it's really nice that we can, in the mini-canron language, describe the routes of an airline network based upon that table of direct flights, and programming the transitive closure and searching to find routes in a network like that. I've never been somebody who works at the counter at the airlines, but I could certainly imagine that I would rather have this than writing it out in racket by hand. And one of the things that's neat about this, being an embedded DSL, is that we can also call out to the host language rather than writing that relation out by hand. We can pull information from online somewhere, slide that information into a relation, hide it under the hood, and my programmer can use that like they would have used any other relation mini-canron. And we can find flights along airports and places that I've never heard of from a big long list. So DSLs are nice, useful. My students should be able to learn to program in it, and there's important benefits of having factually an embedded DSL that we can get. There's neat things that you get from working specifically in an embedded domain-specific language that you don't get elsewhere. But when it goes bad programming in an EDSL, you can end up with the things that that beginners didn't like about error messages before, but worse. So I'm not going to quiz everybody on what it is that this program would do when we ran it, but because the fresh syntax is incorrect here, for mini-canron reasons, I'll get fresh bad syntax in fresh ST. And you might be asking, where's the ST identifier in this program? Where did I make a mistake of writing ST, says my novice student. And why is the error message dragging me to some other file, line 343, in the middle of the implementation of my language? If I'd left Dr. Racket open, we could go and look at it, but that's the sort of thing that I would expect to terrify my sophomores. Here's another little mini Canron program that we could try writing, and when I run it, so what I've done here is forgotten that some of the semantics, how the mini Canron DSL interacts with Racket's define. I've written an infinite loop here and written an infinite loop in the host language. We haven't even gotten to doing DSL-specific search, and you wouldn't be expected to know that. I'm not expecting you to understand why. The fact that you don't know why this is going into an infinite loop, though, proves my point. So, mini Canron, let's say, gives despicable error messages because these mistakes are transparent throughout the implementation. And everybody who's been working on using mini Canron was designed to be used in a undergraduate context for college students who've had scheme programming as their first and second semester courses. And like even with some careful design and that audience in mind, we found ourselves giving students some pretty nasty error messages, just maybe as a consequence of it being an EDSL. So, I've got a Racket embedding. My students learn very little of Racket, and honestly, they forget a good deal of what they've learned. And I want to be able to effectively teach these folk mini Canron. That's a third example of the kind of EDSL I'm interested and the kind of audience that's struggling with it. So, the prototypical, if I can expand out a little bit, idea of the kind of thing that I'm considering are, imagine shallow embeddings of a language where the user actually has some long-term commitment. This isn't command line arguments DSL that they import one off and throw away, or how specifically we write regular expressions in this host language. It's something where I imagine they want to be a Mimi programmer, or they want to be a mini Canron programmer. And they want to learn, or have been voluntold to learn, where hopefully the time that it takes to learn that teaching language and then scale up from the teaching language to the next is less than the time it would have taken them to learn the full language on its own. That's the kind of audience that I have in mind, and I felt it's worth pointing out that that's not our typical community. I don't know too many of these folk who are in the audience at ICFP, and these folk tend to be kind of underserved as a population. So, making teaching languages is hard, making DSLs can be hard, hosting DSLs properly is the thing that can be hard, and there's some unique or particularly acute challenges with teaching embedded domain-specific languages to novice programmers. But I think maybe this is there's maybe a small problem here that we can pull out to work on specifically the novice audience, and maybe this is something that we can actually have a chance of grappling with some part of this. That's not to say, though, that the benefits of this are isolated or limited just to a teaching audience. Had the idea that things that make programming better for students, if we can improve the state of IDEs or host languages, for instance, things that might make it better doable for students could also be really useful tools for for more experienced developers switching to a new language. There's this idea of the curb cut effect. And the idea is this: you've likely noticed at intersections, lots of intersections now have a little ramp down. They've cut out some of the curves so people that are in wheelchairs can can easily hop down that curb. And this is an important thing for accessibility for these folk. But we've also found how much nicer it is for people using a stroller, people wheeling luggage around. There's a lot of additional benefits that everyone gets from helping a particular group of folk, and it may very well be that if we can make our hosts better, if we can make the tooling for building DSLs and for student users better, then there's a lot of downstream benefit. So the things that I have in mind more specifically for what I've thought of that students should want is custom or customizable, domain-specific, user-friendly kinds of visualizations. Things for the programs that they're writing, the kinds of programs that they're writing, or maybe programs of the size that they're writing. Especially informative or user-friendly error messages that the students can read, and some real helpful, robust support in the IDE, something that'll help users better distinguish between where's the DSL and where's the host language, even if they're sharing very similar syntax. These are what I'm expecting as a first pass for the kinds of things that students should be demanding, or EDSL users should be demanding from their EDSLs, and maybe the sort of things that EDSL implementers should be demanding that they can easily provide users, that they should be demanding of their host language. And readable error messages doesn't necessarily mean just the technical behavior. I'm also very much interested in thinking about making natural language is another language in which your EDSL is implemented, and the vast majority of people won't be able to read the error messages in the language that you're providing if you're providing it one, and I don't care what your programming language is. You should have in mind some ability to localize the error messages in your EDSL and host, but in EDSL for the vast majority of folk so that you can support the rest of the world. So that's a long list of desiderata, and I've talked a lot about what's wrong, but I want to spend just a little bit talking about some of the things that are right. Some of the one thing that I've had place where we might have be working towards at least a part of the solution. Michael's given me a really grand tour of his syntax spec tool. It's an embedded domain-specific language for designing DSLs, where you can write down grammar and binding structure, and this gives you the kind of pipeline that you would have expected for a general-purpose programming language to have, and it also gives you, the language designer, the ability to hand a bunch of extra tools off to your user. Things like, for instance, macro extension, but also some of the support provided by the IDE. And we can have our DSL and DSL user inherit some of that. So when we make a mistake in the hosted mini-canon implementation, we'll get a somewhat nicer error message. They're not always, some of them are pretty nice. If I mini-canonist get my parentheses wrong, and my beginning students do, hey, it'll take me right to the point of the mistake and say this was unexpected as a term. There are other places where the error messages aren't yet as nice as we'd like them, but because we're writing down the grammar of the language, Michael has it rigged up so that the DSL will report syntax errors in the vocabulary of the DSL rather than reporting them, say, as runtime errors in the host, or worse yet, a program that runs and spits back out vector 17 or something. So This is the point where I want to solicit your gripes and complaints. A lot of people in this room design and build EDSLs. A lot of people at this conference and workshop design and build DSLs. When you've done, a lot of people here are educators. When you're teaching students and you built a DSL for them to use, what kind of problems did your students run into more specifically? What kind of features do you wish that your host provided for you to be able to easily build the DSL of your students' dreams? Or what does the host of your dreams provide that your current favorite host language doesn't? So I want to very shortly open a discussion and get everybody's advice on what else we can add. But for now, let me stop and thank you for your attention. And the floor is now open for gripes and harangues. Please.
So, PhD student, I just started teaching some of students we have at university. We teach them, sadly, Java, but that's besides the point. It's something that I really think about because I learned how to program pretty early on, and I never had to experience this very steep learning curve that you demonstrated. And what leads me to believe is that when you want to learn something, it has to be project-oriented. The problem I see with these DSLs is that they tend to be fixed. Every few years there's a fad, people come in, they want to do a game, they want to do an Android application, they want to do a blockchain, they want to do a web application or something like that. And if these DSLs aren't evolving really quickly with the fads, then I'm afraid some of these students will not stay around because they cannot accomplish the ideas that they want their computers to do for them, you know? And
can I try and rephrase that and then see
please,
if I
go
can
ahead.
address
Yeah,
it?
yeah.
So some of these EDSLs move really quickly. One of the benefits of having an embedded language is it can evolve at the speed of any other program in that host. Some of them come and go away just as quickly. We stopped using Gradle and started using something else for our project build system. Everybody move on. And that's one half. The other half was that we find students like to learn to program in kind of a project-oriented fashion. They want to have something in mind that they've accomplished, not to program, but to some rat's eye level thing to have accomplished. And it's maybe not clear that all of these EDSLs have the space for that kind of thing to, hey, look, Mom, look, Dad, see what I made. Both excellent points. One hope that I'd had was that these families of teaching languages, if you're maybe designing a new EDSL, one possible way of building it that I had in mind would be to build the N-1th version of that language, and then N-2 describe each of the teaching languages as kind of delta's offset of the real one, so that as your EDSL evolves, your teaching languages can all, let's see, if I added a new function to the standard library in my EDSL, all of my teaching languages should inherit that unless I decide that I want to block it there. And my hope was that there's a tail of teaching languages following off the real one, and as that one evolves, that should just be able to carry it there. I was hoping that we'd be able to scale the effort of building and maintaining families of teaching languages down to pretty good for low prices, and hopes that the people who are implementing DSLs can handle the extra burden. So that's one half of and I hope that if that DSL ends up going away, they don't feel like they've wasted their time. The other is that you're right that a lot of people are learning general purpose programming and they want to have some sort of a project and goal. The kinds of people that I have in mind for this sort of audience are maybe even working professionals that are learning to program in the course of doing their job because this is now how we get stuff done. The same way I think you don't put Word and PowerPoint on your resume anymore, the way you don't really get credit for doing your own typing nowadays, it's just expected that that's a thing you'd be able to do. I'm envisioning that more and more jobs will just expect computational literacy, the ability to automate tasks as just table stakes. And maybe you didn't quite have it or you're learning it on the job, but people that I really want to be able to do this climate modeling so that I don't have to do this stuff by hand anymore. And for those folk, the aim of their DSL may very well be the task. It's not look mom, look dad, but hey, look coworkers and colleagues, we've got a problem.
Cool. So I have, I guess, a little bit of a gripe. So I teach Racket in my classes, and I don't generally use the teaching languages for the following reason. First of all, I'm not teaching complete newcomers. They've learned, some language before. And then the second one is that students, I find they tend to like to be a little bit experimental and like to be able to use some forms that maybe haven't been introduced in class, but that they can extrapolate. And a concern that I have is that if I fix them into the teaching languages, they might get kind of frustrated and, maybe just feel like I was kind of, arbitrarily holding them back from using some feature that maybe would be okay, but, it's okay for, for example, set bang I typically prohibit in my class because I feel like it, it fundamentally hurts
How
the
do
nature.
you prohibit that?
I tell students that if they use it, I will give them a 0.
And you have
Yeah.
either a linter or you...
Yeah, we have an auto grader that checks for it, and there are ways around it, but I tend to actually look at a bunch of the submissions. So, it's possible that it could slip through, but I make a pretty big deal about it. And yeah, we do have some infrastructure in the auto grader to check for it. But yeah, that's kind of my concern. I'm not saying it's necessarily a well-founded one. I mean,
Let's see, can I
Sure.
please forgive me, let me try and
Sure,
spit
yeah.
it back and see
Sure,
if...
yeah.
Well, the Seton Hall context, I think we maybe do have a perhaps larger number of students for whom their first programming course is the first time they're doing programming.
Right.
Or maybe they've done like Minecraft, but they haven't really sat in front of a text editor. And maybe that's a bit of a distinction in audience. I know that when Matthias and the PLT crew had this in mind, they were visiting high schools in the 90s, where I think it's a lot more realistic that they hadn't had a previous background in programming. But that's a perfectly reasonable, valid context to work in, and I don't begrudge that. I do kind of wonder if I've seen like a scheme for the Java programmer or Java for the Scheme programmer, and not necessarily the teaching language sequence shouldn't have to necessarily come from beginner. There's a reason that you might want to introduce. In my ideal world, if you give me point A and point B, we ought to be able to provide a series of stepstones to get you there at a reasonable pace. And so I think your students ought to be supported better too. Now, one of those things, the places where I found students get frustrated about seeing features they can't use is because they end up Googling or searching at the documentation and they find the wrong documentation.
Right.
To me, that feels like an IDE problem or a documentation problem.
they're using ChatGPT. It
yeah.
spits
Oh.
it out.
So what kind of features are things that the students really wish they could use and that you are happy to allow them to use?
For example, using match before I introduce match, or introducing, I basically follow exactly this sequence, but I don't use the languages. So I talk about cons before I talk about match. And
So
then
you are aware that there's an additional match library for the teaching languages to which they could have access.
Right. So that could be a solution for sure.
But-
I'm not saying I couldn't.
right.
I'm not saying I couldn't use the teaching languages.
That's a rather particularized, specific instance solution to a more general problem you were describing.
Sure. It's mostly just my preference. And to be clear, these are not first-year students. They're students who have already taken an intro sequence.
Ah.
I think this would be perfectly reasonable for the intro course, for sure. No
Have
doubt
your
about that.
have your students used untyped functional languages before, or what's the
Not
context?
previously either Haskell or Python. So either a typed functional language or, an untyped unfunctional language.
That is. I'm impressed that you don't have to divide your sections into the.
I know, yeah. My course? Yeah. Or my course is just teaching it's a, mid-level, sophomore, junior level PL course. And so I'm teaching, functional programming, but in an untyped setting. But maybe it's worth switching to the teaching languages. I just haven't yet.
I think the teaching languages are specifically designed for the how to design programs curriculum.
Right.
Tying them together with that curriculum. So
Right.
if you're teaching something else, then sort of the teaching language
Have-
that would make sense might be different.
Yeah.
Have you seen Elie Barzolet's? He has a family of languages designed specifically based on a typed racket / PLAI to.
Yeah, I've seen those. They seem good.
It's ideology because I can't help but believe that there's a teaching language which would help address this problem.
For sure, for sure. There very well may be.
Hi. I guess the main thing I was just thinking of is that in the experience I have both with teaching an EDSL and teaching any other computing science problem is I find that when teaching an EDSL, we get a lot of questions of, how do you do X, Y, Z in EDSL? And the answer is, just the way you do anything else in the host. Similarly, when teaching, concurrency, students ask, how do you do this specific concurrency thing in Haskell? And the answer is the way you do this thing in any other language. So in general, I feel like the problem is that students don't know what domain their question is even about. So that's why, like you said, they look in the wrong documentation or they Google for the wrong things. So I think part of the problems is that they don't know where to look because they don't know what their question is even about.
I love it, and how do we fix it?
I don't know.
I mean, I think that's that hits a bullseye. I don't even know how to ask the question is one that I get a lot too. Sometimes, I can divide those in half into the things where they have no idea what the syntax is, but should have, and they have no idea what the semantics is, but very well should have. It's the same as, it's async. That's the way that you do it in your other favorite language from class 1117 or something. But how to give the gist of the EDSL, here's the scope of its domain, here's the part that's just like the host. Our language isn't responsible for packages or for the type system or etc. Maybe, I don't know, maybe it should come with a threefold pamphlet of your DSL and you.
Just write a manual.
Yeah.
I mean, my answer here a little bit is that, with EDSL, the boundary between the EDSL and the host is sort of clear sometimes, right? I think particularly that showed up in that paper about the Mimi kind of modeling itself. I tried to go read the documentation for it. There's a lot of places where it just says expert is allowed here, right? But
Yeah, so there's that. Thank you, Syntax Spec. Thank you, Michael. I guess we can take the rest of this offline or out for beers. Thank you for attending Jason Fest, I think.